A heavy door with door closing system is shown in the figure. The moment of inertia of the door panel about the hinge axis is 20 kg meter square, and stiffness of the torsional spring is 25 Newton meter. Find out the most suitable value of damping coefficient C. Neglect the effect of inclination. A is given as 10. Now here's one thing I might not have pointed out. See, in the question they have not mentioned like what is the type of damping, but they have said find out the most suitable value of damping coefficient. Okay, so this itself indicates that you should choose solve for critical damping, right? Because you don't want the door. So this is the stopper. This is the door stopper. You don't want this door to hit this stopper. All right. So the damping should be only the oscillation. So if this is the mean position, the oscillation should be only on one side of the mean position. All right. And second thing is that you want the door after it is open to close as soon as possible. So all this, both these things can be achieved only by having critical damping. So we have already solved this example, and we solved the example using D'Alembert's principle. All right. So this was the solution. Now we will also solve this example by using the energy principle. All right. So we'll write the equation for the energy principle. So energy principle is kinetic energy plus potential energy is equal to constant. Right. So kinetic energy will be half I theta dot square plus the energy stored in damping, that is the potential energy stored into damping. So that is damping force Fd into displacement dx and integral of this quantity plus the kinetic energy due to the rotation, that is the the potential energy stored in the torsional spring. So that is half k theta square, and this whole thing is constant. All right. So force is this damping force into the displacement, that is a linear displacement. Okay. So that can be written as these terms remain constant. Fd plus damping force is Cx dot into dx plus half k torsional into theta square is equal to some constant t. All right. Now write x is equal to a theta. So dx will be a d theta and x dot will be a theta dot. All right. So substitute all these values in this equation, and so after substituting these values in this equation, so this is my equation. So I will substitute all the value for x dot and dx in this equation. So I get half I theta dot square plus integral C A into theta dot times a d theta plus half a torsional theta square is equal to constant. All right. So this I can write it. This is same. C a square I can take it outside of the integral. So this becomes C a square theta dot d theta, right, plus half k torsional theta square. This is equal to constant. Now instead of writing this in form of d theta, I will just write it in form of d theta by dt times d. All right. So divided and multiplied by dt. All right. So this d theta by dt is again theta dot. All right. So first term remains same plus second term becomes c a square integral of theta dot square dt plus half a dot square. I will just write it here itself. Half I theta dot square. All right. Now differentiate this equation. So right hand side is constant. So differentiate this equation. So first term becomes I theta double dot. Now this term Ca square is constant. All right. So that is why it is outside. It is a constant. All right. Now we have to differentiate this value. So this is like something like integral of function of time. Theta dot is function of time dt. All right. So this is the integral I. If I differentiate this di by dt, I get f of t. All right. And here in this our case, f of t is theta dot square. All right. So the second term becomes plus ca square theta dot square plus a t into theta into theta dot is equal to 0. Right. So theta dot gets cancelled. So and we get our equation I theta double dot plus ca square theta dot plus k torsional theta. All right, is equal to 0. Right, which is our equation. So you are governing. So this is our governing differential equation I theta double dot plus ca square theta dot plus kt is equal to 0, and this is in our standard format. So we get the same governing differential equation if you recollect the content from the last one. All right. Now open your quiz and answer the first question. Question one. Question one is the natural frequency of the system is dash hertz. All right. So when you are entering the answer, write your answer by rounding out it to off to its to one place after the decimal. All right. So for example, if your answer is 7.32, enter 7.3. If your answer is 7.38, you have to enter this 0.08 becomes rounded off to 7.4. If it is 0.056, rounded off to zero point 0.6. If it is 0.51, that is this part is less than 0.5, 0.05, then write it 0.5. I hope that is clear. All right. So now open the quiz and enter your answer and submit it. I hope everybody is clear how to round up the value, right? You have 2 minutes. It will be closed at 12:32.
Sir, could you show the equation again of the
Equation you should know. Equation is the same as that of the last time. Again, when you are
So
writing,
submit, no?
Sir, the form has 7 questions, so we'll have to submit it when we complete
Ah,
all the questions, right?
no, sub one once you enter the first question, submit it. Remaining 7 questions I will activate later.
okay.
Remaining six
Okay.
questions will be activated later. One question is done, you will immediately submit it. All right, you have only 2 minutes, huh? This is not a big deal. Okay, make sure you write the see the you are expected to write the answer in terms of it is given, the units are given. Okay, so read the question carefully. Do not enter units when you are entering the answer. Okay, see, I am giving this instruction repeatedly, but still some students are not following it. So you have to just enter the answer by rounding it off to first decimal place. One place
Sir,
after the decimal.
the form is not accepting answer until all the 7 questions are submitted.
Just a minute, just a minute.
Sir, all the questions have been put as compulsory. You'll have to remove that option, only then we'll be able to.
Just hold a minute. Hold on. Try now. Submit your answer. Submit your answer quickly. Time is up. All right. I'm going to close the
Sir, it is still
response.
showing that 6 questions need to be completed before submitting.
Just refresh the page.
Yes, sir.
Refresh it. Refresh it. Refresh it. Because
Sir,
people are
the problem persists. Hello. It shows the all other questions are also compulsory.
just refresh the page.
The voice is cracking.
Sir, even after refreshing, the 7th question is still compulsory. So
It's compulsory,
we
sir.
have to change it.
No, it is not. Just refresh it once again. It takes a little bit of time sometimes. Just refresh it once again. All right, submit it.
Sir, it's not being submitted. It's still showing it's compulsory, even if after I refreshed it.
Yes, sir.
All right, just fill the answer and keep it. Okay. We'll continue. Submit it at the end. All right. Just those are, if you are still not able to submit it, let's just move on. Just fill the answer in the blank and keep it ready, because there is this internet issue. Sometimes that data transfer, it may take some time. Okay. So we'll continue. All of you have solved the question, right? So I will move on to the next question. Just fill your answer in the blank and keep it as it is, and at the end you can submit it. All right. Or when you are answering the next question, you can submit it. All right. So we will move on. Gaurav, is that okay?
Yes, sir, but after canceling that page and again clicking on the link, then you fill the answer and submit. It is accepting. So
So see, for those students for whom the answer has been accepted, don't worry. For some students, there is some delay because of the internet speed, so it might not accept. So just fill the answer in the blank, because we will not remember it later. Okay, fill the answer in the blank and just submit it.
okay, sir.
Okay. All right. So we'll move on to the next question. Okay. Okay. So I will just read the question. A successive amplitude of a vibratory system as obtained under free vibration are 9 degrees, 6 degrees, 4 degrees respectively. The MI of the torsional pendulum is 600 kg meter square and immersed in a viscous fluid. The shaft diameter is 10 centimeter, length is 40 centimeter, G is equal to 4.4 into 10 raised to 10 Newton per meter square. Okay, determine logarithmic decrement, damping torque per unit velocity, time period of oscillation. So damping torque per unit velocity, it is nothing but your damping coefficient. Okay, it is just CT. All right. All right. So let's start that. So I will just rewrite the data. Diameter D is equal to D is equal to 0.1 meter. L is equal to 0.4 meter, that is the length of the shaft. Young modulus of rigidity is G, that is 4.4 into 10 raised to 10 Newton per meter square. So polar MI of the shaft, that is the constraint. Okay, so that is the so this is the constraint, and to this pendulum is attached. Torsional pendulum is attached. So for this property, this is D and this is the length of the constraint. Okay, so we are first calculating the stiffness of this constraint, right? Stiffness of this shaft. So this shaft will act like a spring. It is acting like a torsional spring. So we have to find the torsional stiffness of the spring. So polar MI of the shaft is pi by 32 into D raised to 4. So that is equal to 9.82 into 10 raised to minus 6 meter raised to 4. Right? K torsional is G dot J divided by L. So that is equal to, so how do we get this? This is T by theta is equal to K torsional, that is equal to G into J by L. This is your equation from the strength of material. So that is equal to 1 point. So substitute all the values in the equation. So you get 1.08 into 10 raised to 6 Newton meter per radian. Right? So omega n is equal to natural frequency, that is K torsional divided by I. So that comes out to be 42.4 radians per second. All right. Make sure you note these values. You will need these values for your calculation. All right. Now we'll calculate the other quantities. Now, if you see the amplitudes of vibration are decreasing gradually. It is a torsional vibration, but the amplitudes of vibration are decreasing gradually. So first one is 9 degrees, second one is 6 degrees, and third one is 4 degrees. So if I take a ratio of this successive amplitude, I get 9 by 6, that is equal to 6 by 4, and that is equal to 1.5. So this shows the amplitude is decreasing, successive amplitude are decreasing, and the ratio is constant. Okay. So the ratio is constant and it is decreasing, therefore this system is under damped. Okay. So this is how you have to determine whether what type of system it is. So this is an under damped system. So first thing we will calculate the logarithmic decrement. Logarithmic decrement. Alright. So that is del. Okay. So that will be natural log of theta 1. So this is theta 1 by theta 2. Natural log of successive amplitude. Okay. So that will be natural log of 1.5, and that comes out to be 0.405. Again, note down the value that we will need for calculation. Okay. Now calculate the, so del is given as twice pi zeta upon square root of 1 minus zeta square. Okay. So this equation we have already derived, or zeta is equal to del, just I am rearranging the terms, then I can write zeta is equal to del divided by 4 pi square plus del square. Four pi square plus del square. Okay. And damping coefficient, torsional damping coefficient. Okay. That is CT will be C torsional critical into zeta. Zeta we have just calculated in the above equation. So this is 2 into I into omega n into, alright, okay. So calculate these values and answer the, okay. Now one more thing is remaining, that is the, just a minute, before answering the quiz we will also calculate the time period for damping oscillations, and that will be TD, that will be twice pi divided by damping frequency, twice pi divided by damping frequency, that is omega d, and omega d, that is the damping frequency, is natural frequency into 1 minus zeta square. So substitute that in the equation and calculate twice pi divided by omega n into square root of 1 minus zeta square. Alright. So calculate these quantities.
Can you shoot back to the previous page? Once.
Done?
Yes, done.
Now answer this quiz question. Alright. So time period for damping, when you substitute the values correctly, you should get this value 0.148 seconds. Alright. Alright. So you do your calculations and answer the question number 2. That is the damping ratio. Okay. So damping ratio you will have to again round it off after 2 decimal, truncate it after 2 decimal. No, do not round it off. So for example, your answer is 0.0325. After 2 decimals, you truncate it. So just write 0.03. Okay. If it is 0.0358, again you have to write 0.03. So after 2 decimals, you have to just truncate the answer. Okay. This I have done just to maintain the consistency of answer. Okay. So first answer question 2.
Shall I have to submit it again or keep it like
submit
that?
it, submit it. If you are not able to submit it, then just keep it. And submit it and just go back. Again, you will be able to submit the, you have to submit the remaining question also. Are you able to go back? Okay, just hold on a minute. If you are submitted it, fine, but don't submit it. Just enter the answers, values, and just keep it. Don't submit it. Submit it at the end of the lecture. Is there any issue with, have you entered the value of question 1? Are you still able to see the quiz? Those who have submitted it. Gaurav?
Yes, sir, we can see the quiz.
And is the value still there in your in your blank space? Whatever value you have entered.
Yes.
Okay. If the value is blank, those who have submitted it, please re-enter the value. And just do not submit the quiz. Submit it at the end of the lecture. Okay, after you are done calculating the damping ratio, just enter the value in the blank space and keep it and submit it at the end of the lecture. Next, also calculate the torsional damping coefficient of the system. Okay. again while writing this value, write your answers without decimal by rounding it off to the nearest possible whole number. Okay. For example, if your answer is 1000.2, okay, round it off to 1000. If your answer is 1000.8, round it off to 1001. All right. So if it is less than 0.5, neglect it. It is greater than 0.5. Enter.
Yeah, so this is for the question we just solved, right?
Yes. Question 3 is for the torsional damping. Yes, just now which you solved. And again, do not write the units. Okay, do not write the units, because for the
Sir, how
question
we have to round off for question?
which question?
So question 2.
Question 2. Question 2. See if your answer is 0.033. Okay, 033. Okay, just truncate the answer after the 2 decimals. So just write 0.03. Okay, if it is 0.038, after 2 decimals, truncate the answers and just write 0.03. Is that clear? There is a person who just now asked the question.
Yes, sir. Yes, sir. Thank you, sir.
Okay. Do not submit the answers. You will not be able to submit the answers. I'll change the setting. Question 4, you have to write the units for the torsional. See, question 4, the units for torsional damping coefficient are, see, you have 4 options, A, B, C and D. Choose the correct option in that. Okay, again, do not submit it. You will not be able to submit it. You are required to submit all the questions before submitting the final. I am sorry for the confusion because there is this again power outage, so this internet speed is slow. That's why the settings are taking some time to take effect. If you have any questions or any issues till the 4th question of the quiz, please ask.
Hello, sir.
Yes.
Sir, first you told that we have to submit question 1, so we submitted it, and now
Okay.
submit it
Okay.
again.
Just you just go back, just refresh the link.
Okay, sir.
And just submit it again.
Okay.
Don't submit it, just enter the values in the blank space and keep it.
Yes.
Any other student has any issues, please, you should notify me immediately. Don't tell me about any issues after the scores are displayed. That is not acceptable. If you have any issues regarding anything regarding the quiz submission or quiz, you should notify that to me before the scores are posted. Okay? Before your scores are posted. All right, we'll move on. I hope everybody is done. Okay, we'll go for the next question. Gaurav, everybody is done? Can I move?
Yes, sir.
Okay, all right. Okay, as the next question, that is, I will just read the question. The rotor of a dial indicator is connected to a torsional spring. So this is a dial indicator, and this dial indicator is connected to a torsional spring at the bottom. All right, and to form a single degree of freedom torsional system, the scale is graduated in equal divisions, and the equilibrium position of the rotor corresponds to the zero scale. So when it is on the zero scale, so this is the zero, it is in the equilibrium position. Okay. When a torque of 2 into 10 raised to 3 Newton meter is applied, the angular displacement of the rotor is found to be 50 degrees. Okay. So when you apply this torque, the rotor, that this pointer is getting deflected by 50 degrees. Okay. When the rotor is released from the pointer, okay, so after twisting the rotor and turning it to 50 degrees, this rotor is released. Okay, after when it is released from this position, the pointer swings back to a minus 20 division. Okay, so it goes back and it goes back to minus 20. Okay, and then after going to minus 20, it again comes back on the other side to plus 5 division. Okay, so 50 degrees is equivalent to 80 divisions, and this is how it is rotating. So first 50 degrees or 80 divisions, then it goes to minus 20, and then again it goes to plus 50. Okay. You have to find the mass moment of inertia of the rotor, the undamped natural time period of the rotor, the torsional damping constant, and the torsional stiffness, torsional spring stiffness. Okay. Now, before we start with the solution, answer the next question. All right. So the question is: the system described in the question is of which type? Overdamped, underdamped, undamped, critically damped, or can it be any one of the above? Depends upon the choice made by the student. Right? So there are 5 options. You have to select the appropriate option and just select and just keep it. Do not submit it. You will not be able to submit it. Done with the selection? All right. I hope you are done. Move on. Okay. Now we'll start with the solution. All right. So first we'll calculate some of the quantities. The first thing we'll calculate is the initial torque applied. Okay. So M0 is the initial torque applied. And that is equal to 2 into 10 raised to 3, 10 raised to minus 3 Newton meter. All right. So this is the okay. Initial angular displacement theta 0, angular displacement is equal to 50 degrees. All right, and that is equal to 50 into pi by 180 radian. That is equal to 0.87 radian. All right. Now, torsional stiffness KT, that is the torsional stiffness, is equal to M0 divided by theta 0. That is equal to 2.29 into 10 raised to 3 Newton meter per radian. Now, what is the time period for the oscillation? Time period for the oscillation, see, it is given that, see, when the rotor is released from its position, the pointer swings first to -20 division in 1 second and then to 5 divisions in the another second. So total time period for the damped oscillation will be 2. Alright, so time period for the damped vibration is 2. Alright, so TD is 2. Now let's see how this vibration is happening. See, if I plot this, right? So initially it is 80 divisions, then it goes on other side, and now it is at -20 division. All right, then it again comes back on the other side, and now the displacement is 5 division. All right, so if you see this graph, obviously this system is, time period is 2 seconds, and this is a system is under damped. All right, so the system is under damped. All right. Now we'll calculate the logarithmic decrement. So for torsional damping, the logarithmic, please write down all the steps. You will be you have to answer the question. For torsional damping, the logarithmic decrement is del, that is equal to natural log of theta 0 divided by theta 1. Okay? And that is equal to twice by zeta upon square root of 1 minus zeta square. So theta 0 is equal to 50 degrees, and that is equivalent to 80, that is proportional to 80 divisions. Okay, 80 divisions. And theta 1 is, now I don't know the how much is the angle, and I don't want it also. I'm not going to convert this. I can just use the division. Okay, so I can just use the divisions which are given, because theta 1 will be proportional to the division. All right, so substitute theta 0 as 80, theta 1 as 5, and calculate the damping ratio, and that comes out to be 0.4037. Okay, so the damping ratio is 0.4037. All right, please note these values. You will be needing this for doing the calculation. Now, the damp frequency omega d will be twice pi divided by the time period of damping oscillation, that is equal to 2. All right, so this will be twice pi by 2, so that is equal to pi radians per second. Okay. Now, undamped natural frequency will be omega d is equal to omega n into square root of 1 minus zeta square. So you have the value of zeta, you have the value of omega d, substitute, and we get omega n is equal to 3.43 radians per second. Right? Now, all right. Now, first step is to calculate the mass moment of inertia. All right. So omega n is equal to k torsional divided by I. So we have already calculated k torsional. We already know what is omega n. Okay, so K torsion is known, omega n is known. So using that to calculate, so omega n is equal to K torsional divided by I. So use this equation. And find out the value of I. Okay. Now similarly, the damping constant, that is equal to the torsional damping constant Ct will be zeta, that is equal to C torsional divided by C torsional critical, cross multiply, Ct will be zeta into C torsional critical. Substitute the values in this equation and answer the next quiz question. Alright. So Mi of the rotor is, now here when you are writing the answer, see it is already multiplied to 10 raised to power minus 4. Okay. So if your answer comes, so suppose 10 into 10 raised to minus 4 kg meter square, just enter the value 10 in the blank. Alright. Similarly, if your answer comes for torsional damping 6 into 10 raised to minus 4, in the blank just enter the rounded off value. Okay, only the divided by 10 raised to minus 4, so it should be in this format. Okay, so write the answer without the decimal and by rounding it off to the nearest possible whole number. Is that clear to all? That is Newton meter second per. Okay. Gaurav, is that clear to all?
Yes, sir.
Okay, so enter the values. And this will be your last question for the quiz, and then you can submit the quiz. Make sure when you submit the quiz, you have all your blanks filled. Don't keep any blanks empty. No, just in case somebody might have no, submitted the quiz earlier, it might happen that when you go refresh the link, that blank space may be empty, right? Especially I think for the first question. Okay, so make sure you have the value is entered in all the blanks and all the choices are selected before the final submission of the this. Any questions regarding this? All right, so already all of you have got the, so let's just finish the your submission, then we'll discuss a few things about your term test. You have 3 more minutes to submit it. It will be closed at 1:10. Again, when you submit the question number 6 and question number 7, do not write units. Okay, units are already given in the question. So do not again re-enter the units. Alright, 2 more minutes. Please now submit your quiz. Alright, all of you submit the quiz. 1 more minute remaining. I am going to close the quiz now. Submit your quiz. Alright, I am closing the form now. Submit your answers quickly. The responses will be closed. Alright. Alright, the responses are closed. Okay. Now regarding your term test. Now, first before going to on the term test, let me just clarify regarding your quiz marks. So I have already discussed this thing, but when some students are not attending the lecture regularly and then they are creating a lot of confusion. See your assignment will have two components. One is your classwork quiz and other is your homework assignment. I have already posted the scores for the first assignment classwork quiz. Homework assignment I have to give. So this I have not given, so that I will give. Your assignment 1 will have these two components. So your assignment mark 1 mark will be average of these two. All right. And I have already posted the the response for all quiz for till date. I think I have posted all the response. If you want to see the feedback for the quiz, you just have to click on the link. When you click on the link, you will see the feedback. All right. Okay. Now, if you have not submitted the quiz, obviously you will not be able to see any feedback. For some reason, if you miss the quiz and then you click on the link, obviously there is not going to be any feedback. Feedback will be there only if you have submitted the quiz when you attend a lecture. All right. No late submission is allowed. Quiz will be if you attend a lecture. In any condition, only if you are attending the lecture, because this is only 1 mark quiz. Okay. For some reason, no, if you are not attending the lecture, then that quiz cannot be again. You cannot be again do that quiz because that has no meaning. All right. The quiz and the lecture is connected. All right. So there is some value to attend the
Excuse me,
lecture.
sir.
Yes.
So I
that?
have submitted the quiz, but when I'm clicking on the link, it shows the form has been closed.
Yes, sir. Even I texted you regarding this yesterday because you said you have to open the quiz link to check for the answers which are correct and which of them are wrong.
Okay. So who is? I will. Who is that?
Smith.
Okay. We'll discuss it after the lecture. Only a couple of students had this problem, so I will discuss.
Sir,
this
no,
thing.
everyone has it.
Who has it? Who has it? Like, have you submitted the quiz?
Yes, sir.
Yes, sir.
Still it doesn't
You are
show.
not seeing the response.
Sir, after submitting, we aren't able to see the response.
Yes, sir.
It shows the
So
form
it
is
shows the
closed.
form has been closed.
Same,
The
sir.
form has been see now. Even now the
Yes,
form
sir.
has been okay. Now the form has been closed. Now I will just okay. Let me do this. I don't know why it is happening. See, I will now post the scores. I am going to post the scores now. Okay, I am posting the scores. Now you can just click the link and let me know if you are able to see the scores. Okay, the scores are posted.
No, sir.
Now just click on your. Just hold on a minute. It will take some time. The net is. Now click on the quiz link. Gaurav,
Yes, sir.
you are able to see the response now?
Yes, sir. Previous quizzes up to 1 second.
Sir, it is still showing the form is closed.
Just hold on. Just give it some few minutes. I have just
So
posted.
this quiz is available.
I can see the answers. See the score.
So
Marks have been
depending
shown.
upon your internet speed, so just we'll give it few minutes for that to get it so that you will be able to see the response. In the meanwhile, we'll discuss about the term test and then we'll come back to this issue. All right. So we'll just briefly discuss about the term test. See, if you are still not able to see the response, I will post the Excel sheet. The Excel sheet will have the response of all the students. Okay. So you can go through the Excel sheet against your name, and in that Excel sheet, the responses are recorded. So that is another way you can.
Yes, sir. Please do that only because here it is not showing the answer.
You should be able to see the answers. Don't worry about it. If you are not able to see the answers, then I will post the what do you say, the Excel sheet. Okay, don't worry about that. All right. Now let's talk about the term test.
So
Yes.
I have one doubt.
Yes.
So in the damping coefficient, we have to take the zeta as 0.064, right? Because
I have
after
told
rounding off, we got 0.06.
Yes, 0.06 you have to take.
So, but originally it was 0.064.
Yes, but I have told you, no, for the purpose of this, let me just open that question. I have told you to take the truncated value, no? See, here it is there on the record. See, if it is 0.0325, truncated after 2 decimals. I have given all the examples. You are not paying attention.
So I thought it should not be
No, there
carry
is no
forwarded
point.
to.
There is no point of thinking. See, all the variations have been given on the screen. See, if it is 0.0358, then again it is truncated to 0.03. Okay.
Okay, sir.
If you are supposed to round off, I will tell you, no, to round it off. Why to give these examples then? Don't
Okay.
wander off during the lecture. Be attentive. See, this your answer will be 0.0645. Okay. So it should be truncated at. This is done so that the evaluation. See, I am trying to eliminate the manual element in the evaluation of the quiz. Okay. It should be as far as possible automated so that it is fair and unbiased. Okay. So you are now supposed to take only this much part. That has been done so that you all of you will get this answer when you round it off. All right. So let's see. I will try to accommodate this, but no, you should follow the instruction as closely as possible.
Sir,
Any
you
other
had
question?
told that means, for another question 6 that you should round off up to 2 decimals. No, the answer was 1.95. Means the correct
Which
answer
question?
that two.
Which question?
Question 6. I have also committed that mistake.
Question 6. What? Just read what is the instruction given. Write the answer without decimal by rounding it off to the nearest possible whole number. All right.
Okay,
So the
sir.
instruction is clear.
But I'm in very hurry. I'm in
Don't be
hurry.
in a hurry. I am doing it in a very slow pace, so that everybody understands and everybody
Sir,
is.
actually there are instructions for every question, but there is not enough time for us to
Yes,
look at
yes, sir.
the question and then solve it. There is very
There
little
is
time.
no time for.
Sir, I mean the time is
2
less
marks
only
out of 7, but all are correct.
Time is less for. I didn't get it. Time is less for what?
Sir, I'm saying there is very limited time for us to solve the questions completely.
See this equation. See, up till this step, I am not asking you to solve the entire problem, right? I am just asking you to solve it partially. See, up till this step, I have already solved the question. Now, all the values I have already calculated for you, right? What you have to required to do? You are just required to do the substitution part and calculate I. How much time does that take? Not more than few seconds. I am giving you at least 3 to 4 minutes for each question. You should not say that there is not enough time. Okay, you have to be attentive when you are attending the lecture.
Sir, we know, but when there are like 2 to 3 values piling up, and then you have to substitute all of them all together, it takes more time than expected.
See,
So
in that case, you should ask that can you give some more time. Only if your one or two students are having that problem, then you should try to cope up. See, again, in this question also, see, I have already given you the solution. You are just required to do the substitution. That should not take so
Okay,
much
sir.
time.
Please, for this one quiz, can you look after that? For
What?
from next quiz, we
That
will take care of that.
decimal thing I will try to accommodate, but time I am providing sufficient time for solving the quiz. All right, that should not be
Okay.
a issue. Time is more than enough for the quiz. Just for substituting, if you are taking so much time, then you should try to really think about your speed. All right. Any other questions regarding quiz before we move on to the term test? This is like it should be attending this lecture should be some kind of challenge, no, some kind of mental challenge, just like doing a formality, that is not appropriate. At least to me, it is not appropriate. I don't know about you. All right, can we move on to the term test? All right. I hope there are. If somebody has any query, you can again interrupt me. But let me just complete this discussion on term test. All right. So your term test 1 is starting from 7th, 8th, 9th is your term test 1, right? Gaurav? Hello?
Yes, sir.
7th, 8th, 9th is your term test, right? So for DOM, okay, the term test, it will be for 1 hour. So you can expect that the total test will be divided into 3 blocks of 20 minutes each. All right. So there will be a block of question for this 20 minutes. Okay. Once this question is answered, only then you will be able to answer the next block of 20 minutes. Okay. When the second block is complete, so after completing first and second block, then you will be able to answer the third block. All right. Once you answer the first block, you will not be able to go back to the first block. Once the block is answered, that will be closed. That's it. Okay. Once the second block is done, you submit it, it will be closed. You will not be able to come back to it. All right. So once the block is closed, you will not be able to come back to it. Okay. Portion for term test. See, I have already the syllabus is already circulated, right? All of you have got it, Gaurav?
Yes, sir.
It is the first 2 modules, module 1 and 2. All right. So one more lecture is remaining. So whatever is remaining, that will be completed in the last lecture. All right. Now, can you please refresh your the links which you have submitted the quiz for today and check if you are able to see the responses?
Sir, will there be any theory questions in the term test?
Anything can be there. Theory, numerical. Okay. Second thing I forgot to tell you, it has been recommended that your term test will have a descriptive component, that is, and it will have your question answer in form of quiz. It will be objective. Okay. So detail answer.
The form is still closed. It's showing the form is still closed. We cannot see the feedback.
How many students are there like this, that they are not able? Okay, one I have counted. Anyone more? Only one student. Okay, so your term test will have 2
Sir,
components.
again also. Initially it was open, but now it is closed.
Okay.
Yes, sir. Yes, sir.
All right.
Not
All
only
right.
for
There can be
this
some
quiz,
time.
even the previous quizzes, they are still closed.
Yes, sir. Let me just what do you say? Complete this. I should not be able to.
Yes, sir.
Today's quiz is also showing that is
Sir.
the form is closed. Once it has opened, then
now it is saying it is closed.
yes,
See,
yes.
responses are closed. You will not be able to see the. Okay, let me see if this will help. Okay, just check if you are getting the email, getting the responses in the email. Okay, I will just Try to do that setting. All right. So if you are not able to see the answers to the quiz or your response to the quiz, then I will post the Excel sheet. So that is not an issue. That Excel, or I will dump all the Excel sheet for all the quizzes that have been completed till date in your Teams profile. So if you are accessing in the Teams, there is one folder called class material, right? Is everybody aware of this? Gaurav?
Sir, no.
Hello? Gaurav?
Yes, sir.
Yeah, is everybody aware of this class material folder on your Teams portal?
Yes, class material is available, but in that previously there were files, but now no files are there.
No files are there. Okay, this might be because of the software, but okay, I will re-upload all the files. See if any such issues are coming, please somebody should notify me immediately. Okay, because I uploaded all the class notes. Yesterday I was able to see even let me just check. All right, I will check that, but I think it was there before the lecture. I
Sir,
checked.
there are only PPTs up to lecture 9.
Yeah, that is true. I have not updated. I don't know whether you are no, nobody's asking where are the remaining PPTs. I just
Sir,
wanted to
but
check.
can you update it?
Yes, I will update it
Because we were
definitely.
waiting for it.
But then nobody's asking where are the remaining PPTs. So I
We
thought
thought
nobody
you
is
would
looking.
update it, sir.
I will update it. Okay. So up till 9 it is updated, and so remaining I will update it today. Okay. And I will update in the same folder. I will put all the Excel sheet of your Excel sheets of your response.
Sir, I didn't get an email also about the feedback thing.
See, I just enabled it. Okay, it might take some time. Okay,
Okay, sir.
so we'll see because there are some bugs with the software. So anyway, I will put all the Excel sheets of all the students of the responses that have submitted till date. Okay, for all the quiz, that is for classwork 1 and uh, classwork 2 is going on, but whatever is complete I will put it in the folder. Okay, so it will be under C. There will be for assignment 1 it is classwork 1, so all the responses will be in classwork 1 folder. For assignment 2 it is classwork 2, so all the files will be in classwork 2 folder. So accordingly you have to look. All right. Okay, so is there are there any questions about the term test? The term test, we will have two components: detailed answers that you have to scan and upload it on the Teams server, and then it will also have a quiz, Q&A quiz that is multiple choice.
Sir, how will we dealing with 20 minutes time? Means if first section is of 20 minutes, if we
So it will not
completed
be
earlier, can
the
we shift
length.
on second or?
No, see that because of that, if I allow that, a lot of malpractices are happening. So that has to be avoided. The question will be proportionate. Okay, the amount of time that will be given for the test for that 20 minutes question will be more than adequate for 20 minutes. So you should not, time will not be again a factor, provided you are thorough with your material.
Sir, all
So
the
within
section
my
1, 2, 3
first
will contain detailed answer and question QA quiz or
Yes.
separate.
No. So one block 1 will have a detailed answer question and a QA quiz. Both the things are going to be correlated. Okay, whatever detailed answer you are writing, the quiz question, that is a multiple choice question, will be based on that detailed answer. It will not be like the quiz will be something else and the detailed answer will be something else.
sir. So if we started a term test right now, so within 20 minutes, we have to do our slot one, submitting
Slot 1,
detailed answer
block
and
1
quiz, all the things.
for block 1. Correct.
And after that, continue to block two means
Yes.
at
Then
every
after
20 minutes
after
we will
20
be.
minutes, the response will be closed. Okay. Beyond that, no students will be allowed to submit the answer. Okay. Then after that, the first block will be closed and second block will be open. Then again you have to solve and submit. Then again after 20 minutes, the second block will be closed and the third block will be open.
So, sir, all these things will be doing in Google Forms, right?
No, in your MS Teams. No Google Form.
But sir, is
Sir,
there
can
any
you
example question on MS Teams?
Uh-huh.
Okay, sir.
Yes. What is the question?
Sir, I was asking how the quiz and test will be taken in Google Forms or something else.
No. It will be in MS Teams and MS Forms. The right now we are doing the quizzes, right?
Right. Got it.
So that is your MS, and you have submitted your assignment last time on Teams. So that will be the descriptive, detailed answer, descriptive type. All right. Any other questions? You already extended the session. Just, if you have any questions, there is one more lecture scheduled on Wednesday. So you can clarify your doubts on that lecture. Okay. If you want, like we
Hello,
can.
sir. Sir,
Yes.
sir. So if, for example, if the test starts at 8 a.m., so 20 minutes will be counted from 8 a.m. or the time from which we open the link.
No. See, link will be. See, if the test is scheduled to from 8 to 9. Okay. So block 1 will be open at 8 a.m.
Okay.
All right.
No,
Exactly
sir.
at 8 a.m.
We had this kind of quiz in MMC, but there was problem in opening the link. So in that case, what we can do?
See, in that case, we will see. As you know, the links I have supplied the links well in advance. So you should check well in advance that whether the links are functional or not. Okay. It will be in the similar format as we are doing our lectures.
Okay.
And sir, while submitting, what if we get a network error?
Network error, see, keep your mobile handy. I hope you are using your landline, some kind of network. No, mobile net is not reliable. See, today we are doing it on mobile because again, there is a power outage in my place. So as you can see, preferably it should be a landline connection. But if you are using mobile, then it's fine. No. And no, I haven't seen that people are not able to use mobile. Mobile net is already always on. If there is a network issue, then it should be notified to me immediately.
Yes, sir. Sir, can we leave now, please?
Yes, please. Okay. Those who want to leave can
Thank you,
leave.
sir.
Those who want to leave can leave.
Sir,
If any other student have any questions,
the
the
last
lectures
part of
have
module 2, that is conversion of multi-masses multi-dampers into single spring and dampers.
Yes. We will take that during the next lecture.
Okay.
Okay. Those who want to leave can leave. Since today, since it is my last lecture, if any students have any doubts, they can ask. Except for this, what do you say? The term test response. I am going to give the Excel sheets. So first go through the Excel sheet and then you can come back with the doubt. Especially the two students who are asking me something yesterday.
Yes, sir. Thank you. That was the only doubt remaining.
So I will give the Excel sheets today for both classwork 1 and classwork 2 till date, and then you can go through your responses, and then if you have any questions you can come and ask.
Okay, thank you.
Okay. All right, that's all for today. Okay, thank you. Sorry for keeping you late. Bye for now.
Thank
Bye.
you, sir.
All right.